Welcome to today's session. My name is Brad Tewksbury. I'm part of the business development team in the database group here at Oracle. And we're going to spend today's session talking about transforming IT and owning the architecture. So I have with me here Ron Mayfield.
Hello, my name is Ron Mayfield. I'm an enterprise architect with the Engineered Systems team. So I work with customers all across North America and assisting them with their architectures and deploying engineered systems.
So we're going to begin today's session talking about transforming IT and owning the architecture and 4 stages of the architecture maturity cycle. So I'm going to go through this now, and Ron will come back in a next section. Okay, so you have 4 stages of the architecture maturity: the business silo, standardized technology, optimized core, and the business modularity. So let's look at the productivity, the strategic productivity curve here for the value of IT as we go from left to right. So as you can see here in the lower left-hand corner, business silo, not a lot of value for the IT group here. Every company today is trying to figure out how to get to that upper right corner. How do they get to that business modularity? So I'll build these out. And what does the business silo environment look like today? It's a lot of disparate systems, pretty expensive to maintain, no single source of truth, and frankly, something that you would probably have seen started 10, 15 years ago. Every IT organization recognizes this is not the environment that to be in. So there's the movement for moving to an enterprise technology standardized solution. So moving to standardizations, though, however, doesn't give you really the cost benefits. As you can see from the IT value curve, there's not a whole lot of gain there. Where the gain really comes is when the next phase, when you go to this optimized core, when you put in this the master data management system, when you get more of an enterprise processing plan in place and that every group is adhering to, that's where you're starting to see some of the value. And then obviously when you get to the final phase, which is the standard interfaces and business componentization, that's really a plug-and-play environment, right? Ultimately, that's the holy grail. That's where everyone wants to get to. So how is IT budgets, how are they affected as we move through these 4 stages? You can see in the, starting with the business siloed world, if that is 100% of your IT budgets today, when you move to standardizations, by the mere fact that you're getting some standards in place, you're going to have some cost savings. But the key here, again, as you go forward, is how do I actually get increase to the IT budget because I'm adding value? And that is in turn, you'll see here this the value cost still is going down in the standardized technology phase, and it's going to be going up when you get over to the end of an optimized core. The next graph line there that we put through these 4 stages is deploying new enterprise technologies and the level of effort. No surprise that by the time you get to that modular phase over in the business modularity area, very simple, right? Because you've got a very plug-and-play environment to work with. So, so lack of agility, cost goes down, and if you see that on the right-hand side, as the increase in agility, the value goes up. And where every customer is trying to get to, every IT shop is trying to get to, is how do I take that data center from a cost center to a profit center? Which is to say, how am I going from seen as just spending money by the business groups to actually adding value? And how do we bring these 2 groups, the business users and the IT groups, together so that there's actually more of a synergy? So people ask, where can the cost savings come from as you move through? I'm just going to bullet out here the 4 categories of IT work: business projects, IT internal projects, infrastructure changes, and break fix. So as you can understand, the unplanned work and break fix, as it sounds, this is where a lot of money is being spent today, right? When you don't have standards, when you have multiple systems out there, a lot of let's say data marts, one-off data marts. Each one of them is having issues. You're spending a lot of resources and time trying to fix these. When you move to that more, over to the more of a business modularity, that's where you're really focusing on business projects and stuff, application logic, stuff that's absolutely having a direct effect on profitability for the businesses. So let's map this out and see how these four areas of IT spend are mapped up against these architecture maturity. So you can, not surprising, right? Business projects today in a siloed world, not a lot of effort being spent there. As you move out to the modular, business modularity standpoint, this is where business projects, right, can be set up in days, even if maybe even hours. So an example would be if I've all of a sudden got a database as a service set up, and I want to lob, a new database, I can call down to my IT department. Because the infrastructure is all set up, I can, within an hour or two, they can turn on a new database for my HR department, for example, if that was who was asking about it. So the goal is, how do I move my, as I go through these four phases, look at where the break fix cost is going. So again, the value is really in the red bars here. So how do I increase those at the same time minimizing the blue bars, which is the unplanned work? And just by the fact of going through these stages, by getting to a business modularity phase, you're going to have much more of a, obviously a common single source of truth infrastructure, which is going to allow for business projects to be the key area of focus, not doing basic plumbing, such as the unplanned work or the break fix. So pretty straightforward, I think, but again, you need to understand how these four phases work together, and how you go from one to the next are all key understandings. So I'm going to pass it over to Ron now, and he's going to talk a little bit more about the various architecture plays that fit into this architecture maturity.
As an enterprise architect at Oracle, I've worked with many customers as they go through the architecture maturity stages. And during these processes, we see common themes and patterns. As an example, when a customer is going from business silo to standardized technology, we have discussions about infrastructure architectures. As they go from standardized to optimized core, then we talk about application and information architectures. And then going from optimized core to business modularity, that's when we talk about enterprise architectures. And again, during these discussions, we see patterns over and over. And the first one we talk about is performance and scalability. That's foundational. Everybody needs high-performance systems that can scale over time. But we also hear a lot about simplifying IT. So I consider that foundational also. That simplifying high-performance, scalable systems, those are the ones that we build off of for the rest of the architecture maturity stages. Now, going from business silo to standardized, we talk about standardization and consolidation. Then going from standardized to optimized, integrated architectures, and eventually we get to what is a modular architecture. So for the rest of the presentation, we're going to talk about these 5 categories: performance and scalability, simplifying IT, standardize and consolidate, integrated architecture, and modular architecture. Now, the research from Dr. Ross in the Enterprise Architecture Strategy book, where these 4 architecture maturity stages comes from, has shown that you cannot skip stages, that this is a maturation process, and each step builds on the previous. So now I'm going to turn it over to Brad, and he's going to talk about performance and scalability.
So you heard Ron talk about performance and scalability, so let's dive into that a little bit. So when you talk about systems in place today in IT departments, you're most likely seeing a lot of build your own, best of breed. And what does that mean? That means you have a database from one vendor on a number of different operating systems to choose from: VMs, hypervisors, disks, network, CPU, lots of different things you can choose from. And you can see that most of the systems in place today, customers have a variety of these components all working together. The point is, there's really no commonality, they're very expensive to support, and they're not really that performant. So an alternative is looking at these engineered systems that Oracle started putting in place six and a half years ago, Exadata being the first one. And what is, again, let's quickly refresh, what is an engineered systems, and specifically Exadata? It is a combination of database servers, network switches, and storage technology, all engineered in one system. And the idea here is you're compressing a lot of the technology that you would get in the best of breed into one engineered system. And when you do that, not only are you getting increased performance, and this performance can increase workloads. We've seen anywhere from 2-3x improvement up to 10, 15x, depending on what kind of workload you're running on these systems. So you're really also what you're also doing is you're creating a standards based solution inside your IT department. I've talked to numerous customers about the value of what they're seeing with Exadata, and one of the consistent themes that comes back is them talking about how they spend very little time now on tuning database infrastructure. This system, the Exadata system that we've put in place for them, basically we've engineered all the difficult components and put these things together so that they don't have to spend time doing tuning, load balancing, these kinds of things. And another way to think about it is every single customer that has one of these Exadata systems is really an extension of your IT department, because they have the exact same configuration. May have if they have an older model, they may have different chips, an older chipset, but by and large, it's the same configuration. The only thing we're doing as Moore's Law moves along, we add in faster chips, bigger disks, things like that. But because of this, leveraging other customers who have the exact same system, anytime someone would find a problem, they call it in, a ticket, Oracle fixes it. That's one bug or one issue that you will never going to see. So fast forward 6 years of doing that, you can see that these systems are extremely stable and extremely cost performant. So we do have different sizes of these systems as well. Based on what kind of workload you're looking at or what your project is, whether you're doing a one-off project or a consolidation of tens or hundreds of databases, will often dictate what size system you want. So we have quarter rack systems, we have half rack, full rack, and then we have give you the option to tie these systems together in a multi-rack configuration. And you'll see that the InfiniBand switch actually ties these systems together. That's it. Just one switch, network switch, allows you to do this linear scalability. So let me talk about a customer briefly that's actually taking advantage of these systems and getting not only improved performance, but savings across all kinds of areas, which I'll go through in a second. So U.S. Customs and Border Protection, this is a system that they put in place probably 3 or 4 years ago. And just to give you an idea for, do they value this as a mission critical application? For every, I think it is 5 minutes that the system would be down, this would be something like 30,000 people stuck at borders of North America not being able to get into the country. So they look to these engineered systems that we've, Exadata, that is their de facto database platform for really simplifying the old system they had in place. So they had a variety of different storage offerings, a variety of different database hardware configurations. So they set out to do this really consolidation, and you can see really the most important thing here is if you look at the benefits at the top, right? So they have 32 million queries per day, right? They're getting a 10x speed up by using these systems. They have a 1 petabyte of data, and they're replaced quite a few SANs that they were using as their old storage, but because of some of the compression technology that comes in one of these Exadata systems, they were able to, again, cut huge costs by moving lots of storage compressed into these Exadata environments and not have to keep supporting the expensive SANs. The maximum availability, I talked about this being a mission critical application that requires 99.9 uptime. They're getting that. And probably I think the figure that surprised them the most was the cost reduction that they have. Cost savings comes in many ways. It comes in power savings, cooling in the data center, just lack of expensive storage systems that you have to support. So all of these kind of combined is giving them huge performance gains, but also huge cost savings, and they haven't had to skimp on anything as far as scalability or performance or just any of the enterprise key metrics that these big companies look for. You'll see too, if you look at, they started out with our version 2. And you go from left to right in the slide, it's just talking about how they've adopted different generations of the product. So, and as each generation of the product gets more powerful, again, they're getting probably reaping more cost savings. So let's talk about the next section here in simplifying IT. I'm going to have Ron come in and explain some of the key features here.
So many customers ask me, how do you simplify IT? Well, as an enterprise architect, I'm always looking for measures. So I'm going to give you a measure here on what we mean by simplify IT. So if you take that build your own best of breed stack and go through and look at all the possible configurations, all the possible versions that are out there, and then you start adding them up and multiplying them out, you get to some pretty tremendous numbers. So we did this for one customer, and here's the number of configurations we came up with. That's right, that's 154 trillion combinations. And even if we were off by 1,000,000 times, that's still 154 million combinations. So with engineered systems, what we're asking our customers to do is to significantly simplify their environment by outsourcing this complexity to Oracle by going with our engineered systems. So now with an Exadata box, we provide patch bundles, and we provide a tool called ExaCheck that goes through and validates the entire configuration of an Exadata box. So you've now gone from 154 trillion combinations to Exadata, which is all engineered together, one patch bundle. Even if you have 3 or 4 or 5, 6 versions, 1 in dev test, 2 in QA, and a couple in production, you're now looking at less than 10 configurations at most. So 154 trillion to less than 10 configurations, that's what we mean by simplify. I'm going to give you another metric now too. I'm going to use an ITIL term. ITIL is the IT Infrastructure Library. It's a set of standards for IT processes. And it also has standard terminology, and one of those terms is a configuration item. And that's defined as any component that needs to be managed in order to deliver an IT service. So anything you have in your environment that you have to manage is seen as a configuration item. So I'm going to give you 3 scenarios, and we're going to count the configuration items, the CIs. First one is, let's do traditional siloed servers, where you've got 8 databases and you put them on 8 separate servers. So if you go through and you count your configuration items, you've got 8 servers, 8 operating systems, 8 databases, adds up to 24 CIs. Well, typically what we see in these environments is low utilization of those assets because people usually buy for 3 to 5 year peaks. So 10 to 15% is pretty normal. I've seen as low as 3 to 5% utilization of the servers. Now you've got 24 CIs to manage, monitor, patch, and backup. This is server sprawl. And this is a lot of the reason why virtualization, specifically hypervisors, came out. So now let's virtualize this environment. Let's take those 8 databases and put them on 2 servers, but add a layer in, the hypervisor. Now if you go through and you count your CIs, you've actually increased the number of things you need to manage. I've had customers that have done this. They've gone through, I had one customer who went through a 2-year virtualization project to try and consolidate in their shop. And they reduced their servers, they reduced their cooling, reduced their power, they achieved all those goals, but they were still running around with their hair on fire because they were just as busy. They had more things to manage. So utilization of your assets goes up because of virtualization. You can over-provision, but you've got a new layer in there. And virtualization can be as much as 15 to 30% overhead in some technologies. And now you've got more things to manage, monitor, patch, and backup. So this solves server sprawl, but it doesn't solve CI sprawl. So Oracle has addressed this problem with our 12c database to break that CI sprawl problem. And we've introduced the 12c multi-tenant database, pluggable databases. So what we can do is take those 8 databases, and instead of them having them standalone, we can now plug them into a container database. And now when we go through and count our CIs, we just cut our CIs in half. So what we're effectively doing with the 12c multi-tenant database is virtualizing at the database tier. See, the real definition of virtualization is a layer of abstraction between a resource and its usage. Virtualization doesn't mean hypervisor. So in the 12c multi-tenant environment, you can see we've only got 14 CIs to manage and monitor. That's a 50% reduction in CIs. Since patching and backups are done at the container database, not at the pluggable database, at the container database, you only have 6 CIs to patch and backup. Utilization of assets goes up, and as we'll see here in a little bit, processing overhead goes down. So with 12c, we solve the server sprawl problem and the CI sprawl problem. Now next we're going to talk about standardization consolidation. That's the next step in this maturation process. So Brad's going to come back and talk about that.
Okay, so let's look at standardize and consolidate, and what does that really mean when we talk about databases. So let's say we have an ERP application, we have a CRM application, a data warehousing application. The way they're set up today, right, is each one of them has their own set of, it's got its own set of resources, right? So you've got memory, you've got CPU and disk set up for each application. Not a very good use of resources at all. In fact, quite expensive. So what Ron was just alluding to with this whole multi-tenant platform that we've come up with in 12c, this goes right at the heart of that problem, and really strives to take away all the waste and the cost and do really smart management. So by setting up a container database, you can now, in fact, take all of these databases and bring them into one container. So in fact, all 3 of these applications now are using one set of resources. So what are the benefits there? So we've actually done a test where taking 20 gigabytes of memory, how much consolidation could you do outside of a container database? And you'll see here by looking at the chart that after about 50 databases, we maxed out the memory. By moving to 12c pluggable databases, you can see that really at 250 databases, that's really where the memory was maxed out. So a huge improvement here as far as system resources being saved and shared. And this is one of the reasons that this particular feature in 12c is one of the most talked about and requested features for customers to learn more about. So when we talk about now a 1-2 combination of taking this huge performance gain of system resources and now applying that to these engineered systems, whether it's Exadata or superclusters in this picture, now you're getting the best of both worlds, right? You're getting a maximum performant engineered system with a highly efficient feature of container databases for any kind of consolidation project you want to have. So these container databases can be set up and utilized in a variety of different ways. Whether you want to set up by versions, by SLAs, by departments, a variety of different ideas and concepts are available. Okay, so as you go through this standardized consolidation exercise, there's some organizational changes that take place. And Ron's going to come in and go through that briefly now.
So as you can see from the slide that we've got this build your own best of breed stack. And what we see our organizations, IT organizations doing during the standardized phase is building out an organization to manage each layer of the stack. So you get this horizontal tiers with horizontal orgs to match each layer of the stack. And with engineered systems, what we're asking you to do is to simplify your environment, standardize and consolidate, replace those with a single engineered system, and then to think about moving your organization over to a vertical organization such as the database machine administrators. Now, what this allows our customers to do is to significantly increase their agility. So again, I'm big on measures. Here's another measure for you. How long does it take you to provision a database? Working with my customers, I typically hear 3 weeks to 3 months. And take a step back and say, 3 months, why does it take that long? Well, if you look at the processes in an IT shop, typically what happens is somebody calls the DBA and says, I need a database. The DBA puts out a service request. It's then passed down to the OS team. It goes in their queue. 3 or 4 days later, they get to it. They allocate the server. Then it goes down to the next layer, stays in their queue for a couple days, goes all the way down, and then all the way back up. And that's why sometimes it takes 3 weeks to 3 months just to provision a database. Well, I was working with a customer that had Exadata, and I asked them, before Exadata, how long did it take you to provision your database? And the response was, provisioning hell. Then I asked this DBA, since you've had Exadata, what's it like now? And the response was, I can provision a database anytime I want. So, but they changed their organization to match the technology to be able to take full advantage of the technology. So this is one of the biggest changes from going from a standardized phase to an optimized core. To go away from the horizontal tech stack and the horizontal organizations to instead to go to a vertical stack and to match that a vertical organization. The net result is we significantly increase an IT shop's agility and their ability to respond to requests for resources. And here's an example. This is the University of Minnesota. They went through a database as a service project. And as you can see from the quote there, it really has transformed their IT shop. And again, we want to focus on the benefits. They consolidated from 40 servers down to 2 Exadata boxes. And here's the big one. They went from 5 DBAs to 3 DBAs. That's a 40% reduction. But that's not a headcount reduction. That means those 2 extra DBAs, instead of doing configuration management tasks, they were able to go and do high-value tasks, like proactively work on business projects, so that when they were deployed, they were stable, so that you didn't have all the break fix. So again, this is freeing up resources, engineer systems freeing up resources, so that high-value tasks can be done instead of low-value tasks like figuring out 154 trillion possible combinations on your configurations. Now we're going to talk about integrated architecture. What do we mean by an integrated architecture is what I always get asked. So first we're going to identify where our target applications are for building out an integrated architecture. So this is a slide that I've done on the whiteboard for several years with our customers. First thing I get them to do is to classify their applications. And typically I do 3, mission critical, important, and departmental. Now the definition of mission critical is if the system is slow or down, it directly affects the cash flow of the business. So what we're going to do is we're going to take those 3 categories of applications and put them on this graph. So let me explain the graph. The y-axis is a level of architecture complexity based on business requirements. So when the end users come to IT and say this system needs to be up all the time, we have a recovery point objective of no data loss. We want a recovery time objective during a disaster of only 15 minutes. And oh, by the way, there's some PCI and HIPAA data. Well, every one of those requirements adds complexity to the architecture, and we can measure that level of complexity. Now the x-axis is the size of the system. How big is it based on several metrics, concurrent users, storage size. So when we map these, we see patterns typically like this, where we see a layer of departmental systems, a layer of important systems, and then a handful of these large mission-critical applications. And on the upper left quadrant, that's typically where we see OLTP applications. They're usually pretty complex, but not all that large, as opposed to the bottom right quadrant, which is data warehouse and now big data. So we see very, very large systems, but they're not all that complex. But with the age of the internet and the requirement for real-time data, we're seeing more and more applications go in the upper right quadrant, which I call mixed workload. This is where analysts want access to data as soon as it hits the system. An example is in retail. As soon as your point of sale data gets input into the system, marketing analysts want to compare that to the last 3 years of data, real time, so they can do online marketing. Now in the bottom left quadrant is your departmental systems. These are small systems, have a handful of users, and they can be down for 3 or 4 days and it won't directly affect the business. So we're doing this exercise to identify those mission critical and important systems, because with engineered systems, with one set of systems, we can cover all 3 of those quadrants. As Brad said earlier, mixed workload. So we can do OLTP systems, we can do data warehouse systems, and we can do full-blown mixed workload all on one architecture. In the database tier, that's Exadata. Now we do have systems engineered for that bottom left quadrant, departmental too. It's like our virtual compute appliance. So again, we cover the whole gambit, but a lot of our focus is going in with an integrated architecture and focusing on those middle mission critical applications. So now that we've identified those mission critical applications, let's go look at an integrated architecture. So we always start with the business requirements, find out what the business needs, map those to applications, then we build out our application middleware and data management layers, and then the rest of the infrastructure, operating system, virtualization, server hardware, and storage. Now working your way back up, that's infrastructure as a service. You add the data management application middleware layer, that's platform as a service. Now you put in the applications, that becomes software as a service. So this integrated architecture becomes the foundation for a cloud solution. And this is what Oracle's been working toward for many, many years. And a proof point here is IDC recently came out with market share numbers for integrated platforms. That's what we call engineered systems. And Oracle is the leader at 47.1% market share of integrated platforms, which is 4 times greater than the second place in the market share. 4 times greater. So this is a really good proof point for Oracle, showing that we are the leaders in these integrated architectures, in the integrated platforms. So now we can take those integrated architectures and deploy them on engineered systems. For the data management layer, we have Exadata. For applications and middleware, Exalogic. For BI, for running in-memory analytics, we have Exalytics. And we've also engineered some of our applications. As an example, eBusiness Suite, we now have in-memory applications that run on engineered systems. So this becomes a complete integrated architecture, top to bottom. Now the next step is to take that integrated architecture and make it modular. So the way we do that is we take that integrated architecture and we add other enterprise architecture components to it. We start with an enterprise integration architecture. Now let me explain that. For the last 10 or 15 years, our industry has been moving from data tier integration to middle tier and application integration. We want to get away from that database interfaces where we have to rewrite a lot of validation code, and instead move the data movement between the middle tiers where we've got code for validation already in place and it can be reused. That's a SOA architecture. So we have a full-blown SOA suite to handle that, but we also still have data integration products like Golden Gate. But that is an enterprise integration architecture to be able to integrate data easily through standards-based products through the entire stack. Now next comes an enterprise security architecture. And that's the ability to have things like single sign-on, access management, role management across the enterprise. So as you add new applications, they can be folded into your enterprise architecture for security. Then comes enterprise master data management. And this is where you're now controlling input of information and data cleansing across the organization so that you have very good data quality. So no matter how many systems that you have that have customer information, you're validating against a master data management customer hub to make sure you're using the same customer information across all systems, which then allows you to consolidate that information in data warehouses and get a true 360 view of our customers. And the last piece of the puzzle is enterprise process management, which is working toward common processes across multiple business units. And you can get great economies of scale throughout the organization by doing this. And this is what we mean by a modular architecture. by adding these other architecture types in, like integration, security, master data management, and business process management, you now have an architecture that allows you to plug in new technologies. So if one of your customers says, we want to do mobile, if you're back in the standardized phase, you don't have these enterprise architectures in place, that becomes a big project. But in an architecture like this, it becomes fairly straightforward to bring that mobile technology in, integrate it through your integration architecture, and overlay it with your security architecture. That's why we say as you get to optimize core and business modularity, much less effort to deploy new enterprise technologies. And of course, when you want to deploy this architecture, same platforms, Exadata, Exalogic, Exalytics, and our e-business suite and other applications that are engineered to run on these engineered systems. So this is what we mean by modular architecture. So Brad's going to come back now and do a summary overview of what we've talked about today.
Okay, so let's summarize the three different architectures that we've talked about in phases. So again, we started with this particular slide and going through the 4 stages of architecture maturity. And again, the takeaway here is the strategic value goes up, obviously, as you move away from a business siloed environment to a business modularity. At the same time, IT budgets, while initially going down, ultimately increase because the IT department is adding value to the business at a very rapid pace. And finally, the level of effort to support new enterprise technologies goes way down as you move from left to right here. And the key here is you can't skip steps, right? You have to go through each one. So, and you want to add anything, Ron?
Yeah, I really want to focus on the optimizing the value of IT. That's what we see as the biggest benefit of having an architecture vision like this and getting your organization to focus on moving from the left to the right in these architecture maturity stages. And it really can be transformational for IT shops, the ones that we've worked with over the years, really transformational as they go through this process.
And the key thing here is as you get to that juncture where you're moving from a cost center to a profit center, I can tell you when talking with customers in the past about this, you really get the attention specifically of the CIO and some of the senior management as they really start to see the value of what their group brings, and they can see that they can be considered on par with some of the C-level executives in the business side. So then we have the really different phases of architecture: the infrastructure architecture, apps and info architecture, and the enterprise architecture, and the various stages, Ron, that you talked about that you have to go through. And again, how you can't skip the steps, that you have to go through them in a methodical approach.
Yeah, you need to remember that each step adds from the previous step. That you can't go from simplify all the way to modular. You need to go through standardize and consolidate, integrated architectures, and eventually you get to that modular architecture. So I consider this slide to be an architecture roadmap. These are the steps you need to go through to maximize the value of IT.
And then finally, the modular architecture. And again, you just went through this and talked about the various phases, whether it's infrastructure as a service, platform as a service, software as a service, and then again how the Oracle's engineered systems meld well with this entire architecture.
Yes, and I would say that Oracle is the company best suited to build out this architecture. Oracle has leading applications all the way down to disk technology. So of all the companies that are out there, I believe we have the fullest portfolio of products to be able to build this architecture for our customers and to make it all integrated together, or as we like to say, engineered together.
So hopefully you found this session useful as we've gone through a variety of different architectures. And again, I think the point that Ron ends with there is the key point, is that much of what we talked about today really is only something that Oracle can address. Is having the entire stack of whether it's hardware, operating systems, all the software components that hit every part of the stack, from the apps, the middleware, to the database, not to mention some of the integration components that bring different systems together. So really no one else can address this, which is why when we put these architectures together, they really are, you know, I think one of a kind, but also something that really stands apart for Oracle customers.
Thank you for your time. We appreciate you watching this session. And again, if you have any questions, feel free to reach out to Oracle. We can get somebody to work with your IT shop, an enterprise architect like myself, and we can help you build out these architecture roadmaps. So again, thank you for your time.
Thank you.